Good morning, everyone. Thanks for joining us for the Gas-Pro features update. Just going to wait a few more minutes for everyone to arrive and then we'll get started. Good morning, everyone. Welcome to the Gas-Pro features update webinar with myself, Ed. I'm just going to wait a few more minutes, make sure everyone that wants to watch has arrived, and then we'll get started. So another few more minutes. Okay, good morning, everyone. Let's get a start. So welcome to the Gas-Pro features update webinar with myself, Ed. In this webinar, we're going to quickly cover some new updates coming to Gas-Pro, which we are very excited about. So without further ado, let's crack on. Before we get into the meat of the presentation, just a bit of housekeeping to bear in mind. Please mute your microphones. Let your questions at the end, which you're more than welcome to put in the chat or the question section, or you can unmute yourself and just ask. Generally, the chat is easier. It's easier to police and stuff like that. This webinar will be recorded, and all recording presentations will be available on the website shortly on our usual place. So it's a quick outline of how this webinar is going to run. I'm going to start off with TWA Resume, which is now on Gas-Pro. Moving on to the in-field Pellistor changes, we can quickly change gas you're looking for, the LEL gas you're looking for. Moving on to the hydrogen cyanide, which is new gas for Gas-Pro, and finishing up with Bluetooth charger updates and what resources are available and next steps. So, TWA Resume, a tried, tested and true TWA Resume function is unique to Crowcon and it's now available on the Gas-Pro as well as the T4 devices. Just a quick summary that our patented TWA Resume function improves health and safety compliance by making it virtually impossible for any operator to breach a TWA limit. This keeps operators safe from overexposure throughout their shift and makes it easy for companies to prove compliance and defend any legal challenge. But let's go back a few paces and work out where TWA comes from. So this all stems from workplace exposure limits. And we all know that large-scale flammable or toxic gas releases can be extremely hazardous to health and can ultimately end up with death. But prolonged exposure to lower levels of gases can also cause significant health problems, particularly if it occurs over a long period of time. And H2S is a really good example of this issue. Depending on the exposure over a long time, results in different symptoms. So if you have a low level over a prolonged exposure time, you could just have painful skin rashes or irritated eyes. Not particularly pleasant, but by no means near death. Then moving on to the mid-level, your blood pressure could decrease, have headaches, loss of appetite, and even weight loss. And then moving to high level, you could end up in a coma with brain or heart damage or even death. So workplace exposure limits generally come from two areas. In the UK, comes from COSH, which is the Control of Substances Hazardous Health Regulations, and they define the workplace exposure limits, commonly referred to as WELS. In the US, the Occupational Safety and Health Administration, OSHA, define the permissible exposure limits, or PELs. Effectively, these are they have the same intention. In the UK and Europe, they basically all share the same WELS. And other places like the Middle East, they generally follow the US standards. If you want more information, there's health and safety executive documents, which are specifically for the UK, but can be transferable. So if you go to EH40 document, which are the workplace exposure limits, you can get the breakdown and how the calculations are made. And the HSG 173, monitoring strategies for toxic substances. So the WELS are then broken down into the short-term exposure limit and long-term exposure limit. The health and safety executive stipulates the WELS for the toxic gases. And the WELS are averaged over the 15 minutes or 8 hours, which is where you get your STEL or your LTEL from. And the short-term exposure limits and long-term exposure limits are known as time-weighted averages and are usually defined in parts per million. It's worth noting here that 8 hours is considered the standard shift length. It's not a cutoff. So if you have a shift that overruns or is generally just longer than 8 hours, you are still covered because it's the average over that time. Even if it's 12 hours, you still have the average per hour is effectively lowered. So you're still covered. So having a look at a few examples here of highlighted carbon dioxide, carbon monoxide, and hydrogen sulfide. And you can see that there's a definite range of LTEL and STEL exposure limits. So because carbon dioxide is present in the air we breathe anyway, and obviously it's the gas we breathe out, it's relatively common compared to some of these others, which is why the limits are significantly higher than the rest. Now, if you look at carbon monoxide, which we all know is particularly toxic, it prevents the oxygen getting into the blood. The STL and LTEL are lower, much lower than carbon dioxide because of its toxicity. Then looking at hydrogen sulfide, with it's even more dangerous in carbon monoxide and causing those awful side effects. Those wells, or STL and LTEL, are significantly lower as well. It's also worth knowing that obviously the relative air density, if it's between 0.8 and 1.2 of air, because air is 1, you can generally consider it to behave a bit like air. But carbon dioxide generally will sink because it is much denser than air. Okay. I've just been informed you couldn't see my presentation, which is awfully embarrassing. Can someone post a chat if they want to start again, or if you're happy with me continuing where I left off? Okay, right, I'll carry on where I was. These slides will be available at the end of today, so you can review them in your own time. I really apologise for that. It's really embarrassing. Okay, so I'm just going to quickly flick through the first few slides. Okay, so that's the slide I was on. I'll basically just finished that, but I'm going to caveat what I just said with the figures in this table are assuming normal ambient pressure and temperature, volatility and risk. So volatility and risk vary according to conditions, and the gas mixes with relative densities, as I said, can be considered to behave a bit like air. Anything that falls out of those parameters is either more dense or less dense than air, and either will sink or rise. Okay, so TWA Resume and how this fits in. After powering off a detector mid-shift, the detector will then assume, when it's been turned back on, that it's a new shift. With TWA Resume, that will not happen. It will give you the option to resume the shift. I'll show you a quick demo in a minute of how that happens. But because it continues the calculation from the first half of the shift, it will ensure that you never exceed TWA limit. So I've got a graph on the left-hand side showing an hourly H2S exposure in ppm. And as you can see, the worker starts at 8 o'clock, turns off the device at about 12 o'clock for lunch. And it might be that they're going in a car with some friends and don't want the detector on. It might be that they're saving battery. It might be that the beep is really annoying. They don't want to have the beep on. Whatever the reason, there's loads of reasons. We can just guess as to why. But when they turn the detector back on at 1 o'clock, that detector will assume that it's a new shift and will start again from 0. And when the worker at 3 o'clock exceeds their TWA, that detector won't know and it won't alert them. So they'll be working at that point beyond their TWA limit and be exposed to harmful levels of H2S in this example. With TWA Resume, once the worker resumes their shift, they power the device back on at 1 o'clock. And it will ask them to resume their shift. They basically say yes. And at 3 o'clock, when they are overexposed to H2S, their detector will go into alarm, and that's that worker's workday over, so they don't become overexposed. We are the only detector manufacturer with this function. It was traditionally on T4, it's now on Gas-Pro as well. It's the only way to accurately ensure TWA compliance. It's also worth mentioning that TWA alarms are stored in the detector logs and can be easily transferred to our data insight solution, Crowcon Connect. So before I show you an example of how this works, it's very similar to the T4. Our patent remains, it is patented technology, so it's only available on our Crowcon devices. No other manufacturer can do this and can guarantee worker safety over their entire shift. So like I just said, it makes it virtually impossible for any operator to breach a TWA limit, and it's incredibly easy to do. So hopefully the internet connection works and you can all see the video. Again, if you can't, it will be online later. So you turn your device on as normal. The resume shift option pops up. You press the button to resume the shift. Nice and easy. This time, if you don't want to resume the shift after turning the device on as normal, you just don't click anything and wait for the 10-second timer to run down. It really couldn't be any simpler. It's also worth knowing that after the 8 hours has gone by, that countdown timer won't appear. So it only appears if you're within that 8-hour window. Okay, so moving on to the in-field Pellistor changes. By allowing Pellistor corrections in the field, Gas-Pro detectors give customers the flexibility to test for a variety of flammable gases conveniently and with no need for multiple sensors or detectors. Users can continue to calibrate using existing methane canisters, saving time and money. So these are the gases that we have that you can choose from the Pellistor settings. And when it comes to detecting hydrocarbons, you often don't have a cylinder of target gas available to perform a straight calibration. So use a surrogate gas and cross-calibrate. Now this is a problem because Pellistors give relative responses to different flammable gases at different levels. So with a smaller molecule gas like methane, which is commonly used for calibration gas, a Pellistor is more sensitive and gives a higher reading than a heavy hydrocarbon like kerosene. In order to compensate, we use a cross-calibration factor, which is basically a theoretical response figure for the flammable gas in question, also known as a correction factor. So commonly available gases like methane are usually used for this Pellistor calibration, and as part of that calibration gas that you use. The correction factor is simply used as a multiplier to get the correct calibration level for the target gas. So for example, hydrogen has a cross-calibration factor of 1.2 against methane. So if using 50% LEL methane as your calibration gas, you're calibrating the detector to 60% LEL, so that's 50 times 1.2. So device readout will be adjusted. So the reason we've chosen these gases are that gaseous refinery products include hydrogen, methane, ethane, and propane. And that natural gas consists roughly of 85% methane, 8% ethane, 2% propane, with butane and pentane at 1% each, and CO2, H2S, nitrogen, and helium making up the final 3% between them. Hydrogen sulfide is broken down into its respective elements to give hydrogen sulfur, hence the need for a hydrogen option, since this is recycled back into the plant or is then processed and delivered to customers. And it's worth mentioning that acetylene is a byproduct of the world's most sought after chemical, which is ethylene, which is the constituent of polyethylene, which is mainly used for plastic wraps, films, and carrier bags, to name a few examples. Demand for ethylene is expected to increase by 30% by 2050, and unless the manufacturing process changes, acetylene is still a dangerous byproduct and a hazard of that process that needs gas detection to one of potentially explosive levels. Do you think we have the right gases with the Gas-Pro? Let us know in the questions. I'm going to now give you a quick demonstration of how we can change the gases within the Gas-Pro itself. So you start off by obviously grabbing your Gas-Pro and assuming it's turned on. You're going to double press to access the menu. And you're going to cycle through that menu with 5 separate button presses. You can see the new kind of LEL icon or flame icon. And you can cycle through the menu with that single button press. The options are obviously methane, hydrogen, propane, ethane, and acetylene. If you want to go back, just click the home button. Once you found the gas you want, you can double tap it. I'm just going to pause it here. You can see that the chosen gas is in that top right corner. Around here. Don't you know that when pens work? But yeah, you get the idea of where it is. And it's really easy to change and revert back. And you can access the menu as before. It is that simple. Okay, and last, and ultimately, is hydrogen cyanide. So by adding the ability to detect hydrogen cyanide to another of our established detectors, we will protect more workers from this extremely toxic and commonly used chemical. Not only is this new sensor convenient and cost effective for the purchaser, it also spares operators from having to learn or trust another device type, increasing their confidence and likelihood of correct use whenever HCN may be present. So draw your attention to Crowcon Gas. It's our an education tool that we use. It's especially designed to kind of educate you, our channel, and I guess also your customers on the gases that we detect. Crowcon Gas is normally a one-pager kind of information sheet. It's available from the website, but today I'm kind of going to give an overview on a few slides, but kind of using the same Crowcon Gas format. So hydrogen cyanide is part of the cyano group, which consists of a carbon atom triple bonded to a nitrogen atom. So that's the black and the blue. Now, various elements can bond with a carbon atom to form new compounds, such as sodium and potassium. And obviously, they'll form sodium cyanide and potassium cyanide. With hydrogen cyanide, you've guessed it, hydrogen bonds with that carbon atom. Now, while the vast majority of hydrogen cyanide is produced industrially, it does form in nature in very small amounts. So, for example, when we digest fruit seeds within cherries, apricots, and apples, that breaks down into hydrogen cyanide. Don't get concerned; it's only trace amounts, and it's actually present in the almonds as well. But again, don't get too concerned. But I'm also a little bit concerned of who will be eating apricot seeds. Apple seeds I can understand, but apricot seeds is a new one. Okay, so taking the humour out of it is extremely toxic, even at low doses. So the short-term exposure limit is 4.5 parts per million, which is effectively 0.00045% volume in air. So it's tiny amounts can be lethal. It is normally colourless. Having said that, if it's in a liquid, it might be a pale blue liquid, but it will evaporate off that and be colourless. It's been said to have a smell or a taste like bitter almonds, although it has also been suggested that up to 20% of the population can't actually smell or taste it, even when others can in its presence. So you shouldn't really rely on your taste or smell senses. Obviously, gas detector is much more sensitive. It's slightly less dense in air, so we will collect it at top of a poorly ventilated space. It's worth knowing. And then it does actually pose an explosive risk at 5%, 5.6% volume. But if you compare that to the volume at the top, obviously you'd be very dead if you're in that area before the explosion. So the toxicity is the issue here rather than the explosive risk. So I've kind of crudely put a rough timeline of symptoms against exposure. This timeline, it could be really small. You could be exposed to a lot of hydrogen cyanide at once, at which point you go through these symptoms incredibly quickly and probably skip a few, ultimately losing consciousness and respiratory failure and then death. Or you could have a really slow exposure and really go through these symptoms very slowly. So I'm bringing back the table we saw earlier, but this time I'm going to concentrate on hydrogen cyanide. So the short-term exposure limit, as I said, is 4.5 parts per million within 15 minutes. And the long-term exposure limit is an average of 0.9 parts per million per hour over 8 hours. So it's still minuscule amounts will be fatal. And also going back to that density, it does fall within that 0.8 to 1.2 kind of ratio. So you can assume it behaves a bit like air, but if that's in a very poorly ventilated space, it will rise to the top of that space. So what should you do if you are exposed to hydrogen cyanide? First of all, move to a new location with lots of fresh air. Ideally, obviously you want to go outside. If there is any hydrogen cyanide present, because it is slightly less dense than air, it will just effectively float off. If that isn't possible, stay as low to the ground as possible. Again, that will be where the lowest concentration will be. Call for emergency help while removing clothing, jewelry. Anything that needs to come over the head should ideally be cut off to prevent, obviously, the head being contaminated further. Wash your body with lots of soap and water, ideally by having a shower. If your eyes are burning and you're wearing contacts, remove your contacts and then rinse with clean water for at least 10 minutes. Lastly, dispose of the removed clothing in a bag using gloves, or turn the bag inside out to pick up the clothes and invert the bag around the clothes. Basically, just don't touch your clothes with bare hands. Seal and place in another bag. So there's a variety of applications for hydrogen cyanide, or applications where hydrogen cyanide gas may be present as a byproduct. It's worth knowing that hydrogen cyanide use is decreasing worldwide, and production is limited and closely monitored for obvious reasons. There are still applications around the world for hydrogen cyanide, although most needs for hydrogen detectors are because hydrogen cyanide is produced as a byproduct rather than as a primary chemical. So I'm going to quickly move around these examples I've got here. So electroplating, fires especially are very toxic with hydrogen cyanide because hydrogen cyanide is present and is produced to make plastics. When they burn, they give off hydrogen cyanide as well as CO. So lots of car fires, because cars are generally made of synthetic materials, will give off lots of hydrogen cyanide, and stoves as well, stove fires and kitchen top fires. The materials used in the pans and stuff, they also give off HCN. Gold and silver production, HCN is a byproduct of sodium cyanide, which is used to kind of cleanse or separate the metal from poor quality ores. So yeah, like I said, hydrogen cyanide there is quite prevalent as a byproduct rather than as a kind of a primary chemical. It's also as a byproduct of PCB manufacture. And as I highlighted earlier with the vehicle fires, hydrogen cyanide is actually used as a product to make synthetic plastics, such as nylon. And in some parts of the world, hydrogen cyanide is used as a primary fumigation gas. So most companies have banned the use of hydrogen cyanide as a fumigation gas, but some countries still do use it, such as India. This is especially prevalent within the shipping industry because they have to be fumigated before they go into ports so that they don't transmit rodents and other pests. There's some other examples of applications or where hydrogen cyanide might be present. So there's blast furnaces, gas works, coke ovens, in the production of X-ray films. And again, just to name a few other examples. And lastly, moving on to the Bluetooth chargers update. So Bluetooth chargers are part of this Crowcon Connect offering that we've recently launched, and they enable you to transmit device data straight to your phone rather than through a PC and uploading that way. They'll connect via Bluetooth to your phone and then use your phone's Wi-Fi or cell network to transmit data to the cloud in your account. So they are available now with a 5-week lead time. And I've got a poll coming up in a second, so I'm going to ask you to vote in a minute. And I'll be interested to know if you would be willing to buy the standalone unit, as you can see with the kind of the black connector. And don't worry, guys, if you're in other countries, you'll still have a connector kit. So it's not just a UK plug. This is just for illustration purposes. Or would you be willing to buy a bit of a Crowcon Connect kit for demo purposes, which would include the Bluetooth charger and then have space for all 4 devices: the Gas-Pro, T4, T3, Gasman, and their cradles, as well as the Gasman T3 communications cable, so you can really demonstrate wireless and wired capabilities of Crowcon Connect. So I'm going to hope the poll works. And I'll give you about a minute to put in your answers. It's worth knowing that the image at the bottom isn't exact replica, it's just an idea of what it could look like. I can't see who's voted, but I can see a percent of attendees that have voted. So keep those votes rolling in, guys. Okay, voting seems to have slowed down. Get your votes in before I close it. We've got about 10 seconds. Okay, I'm going to close the vote in 5, 4, 3, 2, 1. Okay, cheers, guys. That was really interesting. It's the first one I've actually used that poll function as well, so thanks for bearing with me. I'll definitely use these results to kind of make my case for it for a demo unit. I think most of you seem to have gone for that as part of a kit. I think some of your questions might be around a lead time of that and a price. I'm still working with the designers for that, so I don't actually have a final price or a lead time. But my ambition is to get it out as soon as possible. We've been kind of promising this for a while, and some of you have been kind of expecting one for a while. So I will try and get it out to you as soon as possible. And we won't be kind of selling it as a huge profit item. It'll be definitely as a way just to get your team engaged. Ultimately, you are part of almost the Crowcon family, so we want you to really get behind this. And to be fair, it looks like you have, which is great. Okay, so just to conclude, because I know that the time is a little bit precious, what resources do we have for these upgrades? So there's graphics for social media that can be available, and feel free to share some of the social media that will be coming out for Crowcon today. I know that some of you have already been sharing some of the press releases, which has been great. We really appreciate that. There's a TWA Resume blog post coming out, which should be today. There's the videos that I highlighted today about the infield Pellistor change and the TWA Resume functions. They should be going up into their respective areas on the website. The data sheets for Gas-Pro will highlight the new gas and capabilities, so they'll be updated today on the website as well. The press release is already out. You should have got emails as well highlighting that. That was a bit of a delay getting the press release to link up with the email, but that's now resolved. And lastly, the HCN Talking Gas one-pager is coming soon, not just to EMEA, but also to the APAC region for the first time as well, which is incredibly exciting. So next steps. Tell your channel or your customers, especially users of T4, Gas-Pro and Triple++, about these updates. I'm sure people that use a T4 will be very excited about the TWA Resume, and people that use Triple++ will be excited that hydrogen cyanide is coming down to Gas-Pro, as well as the infield Pellistor changes. Feel free to share our LinkedIn and Twitter content and use those images. This will be a kind of an expected release from the 2nd of September on all new Gas-Pro products, so you don't have to pay extra for these extra features and functions. And feel free to order T4 Gas-Pro Bluetooth power cables now, or at least give me an indication of how many you would like. We've got an initial order that's kind of a small batch to see how receptive you guys are for this. If we need to order more, we'll order more. Yeah, definitely get your orders in, and I'll try and get that demo unit. And so, from the looks of it, it seems to be the way of choice for you guys. So I'll get the demo unit pushed along as well. Just like to highlight the next webinar, which is in a week's time, same place, regarding confined space entry and explaining that. So it won't be a product webinar; it'll just be an education piece on confined space entry. And that is it from me. I think I've seen a few questions pop up along the way, so thanks for bearing with me while I've answered this. I have a feeling most of them are pretty to do with the fact you couldn't see my screen for a while. So let's have a look. So there's a question about data sheets in German. Yep, they'll be released in English, German, Portuguese, French. It's testing me now of what language we've agreed. Basically, it's every language that our channel is in, or every main language. So that shouldn't be an issue. It's definitely in German. Like I say, there's a question about new features. Hopefully, I've just answered that on the last slide, but they'll be available from the 2nd of September, or at least that week of the 2nd of September, in every kind of Gas-Pro going forwards. If you have any questions, feel free to post them in that question section. I appreciate there's quite a lot of content in that of varying different features. One thing I would like to question you guys on is, have we got the gases right for the infill Pellistor changes. If you think we've got what the industry needs and what your customers expect, then perfect. But I'm more than open to having a discussion on actually what is the most common gases that you guys or your customers want to be seeing. So excellent. So I've got some questions here. Do you have the videos without audio to make videos in their native language? That's from Christian. Yes, I can make that happen. There's no in the videos that I showed, it's only me talking over it in the webinar. They don't have any voiceover in the actual video. But if you want me to take the English captions off, I can do that so you can speak over it. It's entirely up to you. There's another question from Mark. Can the older Gas-Pros be updated to the new features? They can, but they have to come back to Crowcon to have that firmware updated. Thanks, Clive, for the feedback that the gas choices are fine. It'd also be really interesting from my point of view if you found the poll easy to use or not. Was it a bit clunky? Did you enjoy it? Did you think, oh, I've got to interact when I do that? It'd be really interesting to know your opinions. In the meantime, is there a cost to have the firmware updated? And that's from Caroline. Do you know what? That's a good question. And I can't give an answer straight away. Caroline, I'm going to get back to you on that question. Cool. Okay, there's lots of questions coming through. Calibrating the new LEL sensors, is it the same? Yep, so absolutely carry on using methane as you were. You shouldn't have to put back the Pellistor setting onto methane when you calibrate. You can use and keep it in whatever gas it is. But if you want, sorry, please, pardon me. If you want peace of mind and you want to put it back into methane mode when you calibrate, like I said, it's a really easy job to do, but it isn't necessarily necessary. Yeah, Clive, I'll get back to you and Caroline regarding cost for the firmware upgrade. When does TWA Resume come on other portables? So I'm assuming that'll be T3 and Gasman. Yeah, we're looking into it. I can't give a time frame. It becomes a point where we've got to be strategic in our resources and say, do you want to concentrate looking at a new detector and look into the future, or do we want to keep sustaining these ones? So it does take development time, but we are looking into it, and that decision making and analysis is happening. Okay, so I think the questions have kind of dried up. I'm very aware that this is probably one of the longer webinars we've run, so I do appreciate your time. If that's it and no more questions, I'm happy to save you guys some time and call it a day, and I'll see you next week. Excellent. Okay, so that looks there's no more questions. Thank you very much for joining, everyone. Have a great morning or afternoon wherever you are.